I'm here with Ian, and I'm going to show him how to balance redox reactions in acidic and basic solutions the way we will do it in AP Chemistry. The steps are all listed right here, but reading them is kind of pointless. It's better just to see an example. So I'm going to go through an example, and then Ian's going to go through an example of how to balance redox reactions. And in this method, you don't have to assign oxidation numbers. That's what I like about it. So, you ready, Ian?
Yep.
All right, let's do it. So, here is the reaction, and it's not nearly balanced or anything like that, but what we're going to do here with this little skeleton is draw out the two half reactions. So, first step is to write separate equations for the oxidation and reduction half reactions. We don't need to know which one's which. We just need to go, all right, chromium, or Cr2O7 2 minus, that's probably going to go with this Cr3 plus, and the SO3 2 minus will go with the SO4 2 minus. All right, so I'm going to write those out on the two separate half reaction lines. Make sense?
Yep.
All right, so then I'm going to look at each half reaction, and we're going to follow these steps right here. The first thing we're going to do is make sure all the elements are balanced except for hydrogen and oxygen. So I'm going to start with this first one here, and the only other element is sulfur, and right now it's balanced. All right, then I'm going to balance oxygen with H2O. So I have 3 oxygens on this side, 4 on this side, so I'm going to add 1 H2O to the side that needs an oxygen. So I'm going to add water to the reactant side. So far so good?
Yep.
All right, then I'm going to balance the hydrogens with H+. Well, since I just added the water here, I'm going to need to add 2 H pluses to the product side. Make sense?
Mm-hmm.
All right, and finally, for the half reaction, I'm going to balance the charge. So on the reactant side here, I have a -2 charge, and on the product side, if I add them up, I got a -2 here, and a +2 here, I got no charge. So I got to balance the charge with electrons. So I have to add 2 electrons to the product side to make both sides -2. Make sense?
Mm-hmm.
So I'm going to add 2 electrons to the reactant side. So now I know that I am losing electrons. This process right here would be?
Oxidation.
Oxidation. Very good. All right, now I'm going to do the same process with this half reaction. Balance everything that's not hydrogen or oxygen. Well, I need 2 chromiums here. Okay, now I can balance oxygen using H2O. I have 7 oxygens here on the reactant side, so I'm going to need
7
H2O.
H2O.
7 H2Os. Very good. Now I can balance hydrogen using H+. Well, I have 14 hydrogens with that water I just added, so to the product side I have to add
14 H plus.
14 H+. Now I got to balance the charge. So I have 14 positives and 2 negatives. So on the reactant side, I have a positive 12. And on the product side, I have 2 times 3 positive. I have positive 6 charge on that side. So I have to add electrons to get the charge equal. Well, what side am I going to add to?
Gonna have to add to the reactants.
Got to add to the reactants to make this less, get it down to 6. So I'm going to add 6 electrons to the reactant side. So I can see electrons are being gained. Gaining electrons is?
Reduction.
Reduction. Very good. Now, all we have to do is check to balance our electrons and add our half reactions together. So I have 2 electrons in this half reaction, 6 electrons in this half reaction. I have to have the same number of electrons. So I got to multiply this first reaction by 3. So everything's going to increase by 3 there. And then we're going to add the half reactions together and cancel the identical species. So the first thing you'll notice is these 3 waters will cancel on this side, and this will reduce to
4.
4. The next thing that cancels is the H+. These will cancel completely. This will turn to a 8. And then my electrons cancel, which they have to in the redox reaction. So now we can add everything together and make sure that the elements and the charges are balanced. Now, I'm going to ensure you that the elements are balanced, but it's always good to check the charge. And on this side, you can see we have a -6 here, and then plus 8. So we're plus 2, and then plus
-2.
minus 2 more. So that's 0 charge. And we're also 0 charge over here. We got a -6 and a +6. So this reaction's balanced. So that's how you balance a redox reaction using half reaction method. You ready to try one?
Yep.
All right, here we go. So, how are we going to separate this first?
All right. Well, it looks like we have NO3 minus and NO2 as one of our half reactions, and the other is going to be the I2 and the IO3. So I guess we'll start with the top one.
Okay.
We balance everything that everything besides hydrogen and oxygen, but we have the ends, and those are already balanced, so that's good. So now we just need to balance the oxygen with H2O. So there's 3 on one side and 2 on the other, so we're going to have to add 1 more H2O to the products.
Good.
So now that we have an H2O, we have H on one side and no H on the other. So to balance that out, we need to add 2 H plus on the reactant side.
Good.
So now we check the charges. So we've got 2 plus on that side and a 1 minus, so that's overall a -1. Positive one. And then on the other side, we don't have any charge right now. So to make them be equivalent, we have to add an electron to the reactant side. And that means if we're adding an electron, we're gaining electrons, so that is going to be our reduction reaction.
Very nice. How about this one?
All right, so we have to balance the elements except for hydrogen and oxygen. So we have I2 and just an I. So to balance that out, we need to make that a 2. So now we have those oxygens that we need to deal with. So we have 2 times the 3 oxygens that are there. So we need to add 6 H2O to the reactant side.
Very good.
Now we have hydrogen on one side and no hydrogen on the other. So we have to take 6 times 2 to get 12 hydrogen plus on the product side to balance those out. Now we need to balance the charge. On the reactant side, we have 0 charge. And on the product side right now, we have 2 times 1 minus, so -2 plus 12, so 10, positive 10 charge.
All right.
So to balance that out, we need to add 10 electrons onto the product side.
Very good.
To get a net of 0. And so if we're losing electrons, this is going to be our oxidation half reaction.
Very nice.
So now we need to check to see if we need to multiply one of the equations by another number to balance these electrons, which we do. So we need to multiply the top one by 10.
Very good.
And so we change everything in the equation to have 10s, and so now we can go about crossing things out. So we know we have the electrons will cross out, 12 of the hydrogens will cross out from the product side, with the 20 on the reactant side of the top, and then we have 10 water on one side and 6 on the other, so the 6 will cancel with the 10, leaving 4.
Very good, my man.
And now we just write it in the ionic equation.
All right, add everything up. Don't miss anything. So we have the I2, 8 H pluses, 10 NO3 minuses, 2 IO3 minuses, 10 NO2s, and 4 H2Os. And everything should be balanced. If you check the charge over here on the reactant side, we're -2, and we're also a -2 on the product side. Very good. Very nice.